You are facing a critical production outage. Your logs are in one tab, Jira tickets in another, and documentation in a third. You spend more time copy-pasting code snippets into Claude or Cursor than actually solving the problem. This is what I call the invisible wall. Even with massive context windows like 200K tokens, the manual labor of feeding the AI creates a massive cognitive bottleneck. We often treat AI like a calculator where we must manually type every digit, rather than an architect who already has the blueprints. In professional environments, context isn't just about the file you are editing. It is about the PR history, the Slack discussions, and the database schema that the AI currently cannot see. This copy-paste hell is the primary reason why even senior developers feel like they are babysitting the AI rather than being empowered by it. We need a way for the AI to reach out and fetch what it needs without us acting as human middleware. This friction is exactly what is holding your 10x productivity back. By the end of this lecture, you will know exactly how to tear down this wall and connect your AI to your entire professional ecosystem. But first, we must understand why our previous attempts at this failed so miserably. In the past, we tried to solve this with LLM plugins, but they were mostly read-only or limited to specific web search capabilities. They felt like static bridges that often broke or required complex custom development for every tool. Enter the Model Context Protocol, or MCP. Unlike traditional plugins, MCP is a standardized, open-source bidirectional protocol that allows Claude and Cursor to not only read, but also act across your local and remote environments. Think of it as giving the AI its own set of hands and eyes. While a plugin is a specialized tool for one task, MCP is a universal interface that connects the AI to your file system, your databases, and your enterprise SaaS tools like Slack and GitHub simultaneously. This architectural shift means the AI can now query your PostgreSQL database, check a linear ticket, and summarize a Confluence page in a single turn without you moving a single muscle. This isn't just a minor upgrade, it's a paradigm shift in how AI perceives your workspace. But wait, is this protocol just another hype cycle, or is there a concrete reason why it actually works in a real-world terminal? Let's look at the actual mechanism that makes this possible. Imagine a world where you tell Claude, fix the checkout bug and update the team. In 30 seconds, the AI identifies the error in your local logs using the Sentry MCP, finds the relevant code in your repo, applies a fix, runs the tests, updates the corresponding linear ticket status, and posts a summary of the fix to the ShopDevAlerts Slack channel. This isn't a futuristic dream, it's what we achieve daily using a coordinated MCP setup. We are moving from AI as a chatbot to AI as an autonomous agent. By automating these microtasks that usually take 5 to 10 minutes each, you aren't just saving time, you are maintaining your flow state. The mental cost of switching from your IDE to Chrome, then to Slack, and back to Jira is what kills developer productivity. With a unified brain, your AI handles the context switching for you. However, simply installing every MCP server you find on GitHub is a recipe for disaster. If the AI has too many tools, it gets confused and starts hallucinating connections that don't exist. So how do we choose the right ones? The answer lies in a structured decision tree that the pros use. To build a professional-grade AI workspace, I have filtered over 30 MCP servers down to a core 7 essentials based on 5 critical axes: code, docs, comms, data, and deployment. You don't need 100 tools. You need a balanced stack that covers these 5 dimensions without overwhelming the LLM's reasoning capacity. For code, we focus on deep repository awareness. For docs, we need more than just a search, we need structured retrieval. For comms, it's about closing the feedback loop with your team. For data, the AI must understand your schema as well as you do. And for deployment, it needs to see the health of the system it just touched. In this lecture, I'm not just going to list these tools. I'm going to show you the golden ratio of how to configure them so they work together instead of fighting for the AI's attention. This setup is the secret sauce that allows senior architects to outperform entire teams of junior devs who are still manually copy-pasting. In the next chapter, we will dive into the first category, the core 4, and see how they form the backbone of your new autonomous workflow. Get ready to see the exact configuration files that make this magic happen. In the real world, code doesn't exist in a vacuum. Most junior developers treat Claude like a simple autocomplete, but senior architects know the real bottleneck is the manual labor of maintaining context across multiple repositories. By integrating the GitHub MCP, you're not just letting Claude read files, you're enabling it to analyze pull request diffs for architectural regression and cross-repo dependencies. Imagine asking Claude, does this new API change in the auth service break the gateway implementation, and getting a verified answer based on actual code across your organization. This setup allows Claude to summarize complex PRs and even suggest improvements based on your team's specific coding standards found in other repos. This isn't just about speed. It's about maintaining a high architectural bar without human fatigue. However, even the best code is useless if your project tracking remains manual. How do we ensure our ticket status reflects our actual progress without switching tabs every 10 minutes? This is where our second core tool comes into play, creating a seamless bridge between the terminal and the board. But before we move on, consider this. What happens when your code review passes, but the project manager still thinks you haven't started? The gap between the terminal and the status board is where trust in an engineer starts to erode. Let's talk about linear. In high-velocity teams, the definition of done includes updating the ticket, but in the heat of a bug fix, we often forget. By connecting the linear MCP to Claude Code, you turn your terminal into a project management command center. When Claude finishes a task and you verify the fix, you can simply tell it to update the ticket and move it to in review. Claude will then look up the relevant ticket based on your branch name or context, comment with a summary of the technical changes made, and transition the state. This eliminates the context switching tax that kills developer flow. In my experience, this automation reduces administrative overhead by nearly 30%, allowing architects to focus on design rather than status updates. We are essentially creating a feedback loop where the code speaks directly to the business logic of the project. But keep in mind, a ticket update is only as good as the requirements it was based on. What if the original specifications were buried deep in a documentation tool? This leads us to the critical need for a centralized knowledge-based connection that informs every line of code Claude writes. If you think ticket automation is powerful, wait until you see how we feed the AI the why behind the features. Coding without context is how we end up with technically sound but business-useless features. This is why the Notion MCP is the third pillar of the core four. Most engineering teams keep their PRDs, API specs, and edge case documentation in Notion. By linking Notion to Claude, you're giving the AI the source of truth. When you start a new feature, you don't just say write a function. You say read the requirements in the Q3 auth refactor page and implement the login logic exactly as specified. This drastically reduces hallucinations because Claude isn't guessing your business logic, it's reading it directly from your architect's notes. I've seen teams struggle for days because the AI didn't know about a specific legacy constraint mentioned only in a meeting note. With the Notion MCP, those constraints become part of the prompt context automatically. It transforms Claude from a generic coding assistant into a specialized domain expert that understands your company's specific quirks. But even with perfect documentation, software development is a team sport. How do we keep the rest of the human engineers in the loop without constant meetings? The final piece of our coordination puzzle handles the human to AI to human communication stream, and it's likely the tool you're already using for every other notification. Communication is the heartbeat of any engineering team, but the noise-to-signal ratio in Slack can be overwhelming. The Slack MCP isn't for chatting, it's for strategic reporting. As a senior architect, I use this to have Claude post automated technical debt reports or architectural decisions directly to the relevant engineering channels. For example, after a long refactoring session in Cursor, I'll tell Claude, summarize the technical debt we introduced today to move fast, and post it to Shepeng internal with a list of follow-up tasks. This creates immediate visibility for the rest of the team and ensures that temporary fixes don't become permanent nightmares. By integrating Slack, we close the loop. GitHub for code, Linear for tasks, Notion for specs, and Slack for team alignment. These core four turn your AI workflow from a solo productivity hack into a professional-grade engineering pipeline. If you've been using Claude without these connections, you're only using 20% of its potential. You've now mastered coordination, but what about the heavy lifting? In the next chapter, we move beyond coordination and into deep system integration. We'll look at how to give Claude the power to search the live web, interact with your databases, and even execute local scripts to verify its own work. Is it safe to let an AI talk to your database? Let's find out in the Technical 3 Deep Dive. In the field, the biggest productivity killer isn't writing new code, it's fixing brittle E2E tests that break every time the UI changes. Traditionally, you'd run a test, see a red screen, go to the browser, inspect the DOM, and update the selector. In 2026, we stopped doing that manually. By using the Playwright MCP server with Claude Code, the AI doesn't just write the test. It executes it in a headless environment, captures the failure, and uses the inspect DOM tool to find the new CSS selector itself. I've seen teams reduce their fixed test rerun cycle from 15 minutes to under 30 seconds. You simply tell Claude the login test is failing on the submit button, find out why and fix it. It navigates the live dev server, identifies that the ID changed from PN submit to submit v2, and applies the patch immediately. This is the difference between an AI that guesses and an AI that acts on reality. However, even a perfect test fails if the underlying data state is a mess. What happens when the test fails because the database schema is out of sync? Let's look at how we bridge that gap next. Managing database schemas while coding is often a context-switching nightmare. You're in Cursor, you have to jump to a SQL client or a web dashboard like Supabase to check if a column exists. With the Supabase MCP, your AI gains a direct nerve ending into your database. When you ask Claude to create a user profile feature, it doesn't just write the TypeScript. It calls the Supabase MCP to list existing tables, realizes the profiles table is missing a BO column, and generates the exact SQL migration script needed. In a real-world scenario where you're dealing with complex RLS, row-level security, policies, the AI can audit your current policies through the MCP and suggest the precise create policy statement to prevent data leaks. This isn't just about speed, it's about accuracy. The AI is working with your actual schema metadata, not an outdated mental model or a stale documentation file. This creates a tight feedback loop where data and code evolve together. But what happens when you're not dealing with a clean cloud database, but a massive local project with thousands of messy assets? That's where local environment optimization becomes the real game changer. One common frustration for developers in Korea is handling massive assets like high-quality Korean font files or heavy localization JSONs that quickly eat up the AI's context window. If you're using Cursor or Claude Code and you accidentally let the AI read a 10 MB TF-TF font or a 5 MB JSON file, you've just flushed your context window down the drain. The file system MCP is your surgical tool here. Instead of the AI trying to ingest everything, it uses the MCP to search files by name or read file offsets. For instance, if you need to optimize a specific part of a massive asset, the MCP allows Claude to peek at just the metadata or the first few lines to understand the structure without overwhelming the session. In practice, I use this to manage pretended or nanosquare font integration across legacy CSS files. The AI can find every reference to these fonts across a 2GB repository without ever needing to upload the binary data. It keeps the brain focused on logic, not binary junk. But does this level of local access pose a risk to your company's intellectual property? Let's discuss the privacy-first approach to local integration. In senior architect circles, we call local-only MCP the secret weapon for legacy migration. When you're dealing with decades-old codebases in a highly regulated environment, you can't just upload your entire source to a cloud RAG. By running a local file system and shell MCP, the AI acts as a temporary guest on your machine. It executes local scripts, searches local grep results, and processes transformations entirely within your secure perimeter. It only sends the specific snippets it needs to analyze back to the LLM. This is how you migrate a massive Java monolith to microservices without a single line of proprietary business logic leaving your site unnecessarily. I've seen this work in environments where even GitHub Copilot was restricted due to data concerns. The principle here is simple. Move the AI's tools to the data, not the data to the AI. It's the ultimate way to respect privacy while gaining the productivity of a 25-year veteran. But as powerful as this is, things get messy once you have to push this code through corporate proxies and firewalls. In the next chapter, Battle Stories, Surviving the Corporate Net, we'll look at how to make these MCP servers actually work behind the Great Wall of enterprise security. You have finally set up your MCP server, and it works perfectly at home. But then you walk into the office, connect to the corporate VPN, and suddenly nothing happens. Claude starts giving generic connection refused errors or simply fails to recognize the tools. This is the classic proxy and SSO wall. In a corporate environment, MCP servers often run as subprocesses that don't automatically inherit your shell's proxy settings. If your company uses a proxy that requires specific CA certificates for SSL inspection, your MCP server will fail silently while trying to reach external APIs. The fix is to explicitly pass environment variables like HTTP's proxy and node extra K certs directly within your Claude desktop config JSON file. Many developers overlook this, thinking system-wide settings are enough, but the AI runtime environment is often isolated. Question: but what if your company uses a dynamic SSO that rotates tokens every few hours? Is there a way to automate this without manually editing config files every morning? Managing secrets for MCP is where even experienced developers get lazy, and that is where data leaks happen. You likely have Slack tokens, GitHub paths, and Jira API keys sitting in a plain text JSON file in your user directory right now. If your laptop is managed by IT, that file might be synced to an insecure cloud or visible to local admins. The gold standard for a distributed team is moving away from the hard-coded config approach. First, never put raw tokens in the config. Use environment variable placeholders. Second, leverage a local keychain or a CLI-based secret manager to inject these values at runtime. Third, ensure your global.jitignore includes any MCP-related log files. Fourth, always use fine-grained scopes. Claude doesn't need owner access to your entire GitHub organization just to read one README. Fifth, treat these tokens like production credentials, because through MCP, Claude can execute real actions. Payoff now. Even if your config file is compromised, the attacker gets nothing but variable names. But how do we prove to the security team that Claude isn't doing something malicious with those keys? Your security officer walks in and asks, what exactly is this AI doing with our private repositories? If you cannot answer with a time-stamped log, you are in a difficult spot. Implementing audit logs for MCP is not just about compliance. It is about visibility and debugging. When Claude makes an unexpected tool call that breaks a build, you need to see the raw JSON RPC traffic. I recommend setting up a lightweight wrapper script or a logging proxy that intercepts every call tool request. This log should record the tool name, the arguments passed, the timestamp, and the original user prompt that triggered it. By storing these in a centralized system, or even a simple append-only local file, you transform the AI from a black box into a transparent, accountable team member. Security teams love data, so being able to show them a table of every action taken is your best defense. Teaser, but even with perfect security, there is a hidden cost to having too many active tools. Let's talk about the performance death spiral. It is tempting to enable every MCP server you find, Sleb, Slack, Jira, Postgres, Google Maps, thinking it makes Claude smarter. In reality, it does the opposite. In the current LM architecture, every tool definition you provide to Claude Code or Cursor consumes system prompt tokens. If you have 15 MCP servers each exposing 10 tools, you are eating up thousands of tokens before you even type hello. This causes two major issues. First, reasoning latency increases because the model has to scan a massive list of tool definitions for every single turn to decide what to use. Second, it increases the chance of tool confusion, where Claude picks the wrong tool because descriptions overlap. I have seen developers wonder why Claude's logic suddenly fell off a cliff, only to realize they had 20 active MCP servers idling in the background, bloating the context window and slowing down response times. This raises a critical problem. How do we keep our favorite tools accessible without destroying the AI's performance? The professional solution is a selective loading strategy. You do not need the PostgreSQL MCP server when you are writing CSS, and you do not need the Jira server when you are debugging a local unit test. The pro move is to maintain multiple configuration profiles. Since Claude Code and Cursor usually look at a single JSON config file, we can use a simple CLI alias or a small script to swap these profiles based on the current task. For instance, a backend profile loads database and Redis tools, while a project management profile loads Slack and Linear. This keeps the context window clean and the response time snappy. You can even automate this by using a shell function that detects the current project directory and auto-switches the MCP configuration before launching your editor. Bridge mastering the infrastructure and performance is essential, but even the best setup can be ruined by bad habits. In the next chapter, we will dive into the specific best practices and anti-patterns that separate the masters from the amateurs. Most developers make a fatal mistake. They trust the AI too much once they see the magic of MCP. I have seen teams grant write access to their GitHub MCP servers and let Claude merge PRs automatically just because the CI passed. This is the ultimate anti-pattern. Even in 2026, LLMs can hallucinate subtle logic errors that unit tests might miss, like a slightly off-kilter regex or a dependency version conflict that only manifests in production. The best practice is simple. MCP should be your highly skilled intern who prepares the work, but you are the lead architect who signs off. Always use a review-first workflow where Claude suggests the change through MCP, but a human must manually trigger the final merge. If you bypass this, you are not building a faster system. You are building a faster way to break your infrastructure. Always verify the diff, especially when MCP interacts with external APIs or cloud resources where one wrong delete command can be irreversible. This approach ensures speed without sacrificing the stability that your users rely on. But wait, what if the tool you need isn't even on the public registry? This is where the real power transition happens, which I will show you right now. Public MCP servers for Slack, Jira, and GitHub are just the hello world of AI integration. In professional environments, especially where we use specific tools like Jandy, CacoWork, or proprietary internal APIs, the public registry won't save you. Industry veterans have already moved on to building custom MCP servers using TypeScript SDK. Think about it, an AI that can query your company's legacy DB, look up internal deployment logs, and summarize messages from local messaging apps all in one context. You should stop treating MCP as a simple plugin and start treating it as a bridge to your company's private knowledge base. Building a custom server isn't just about coding. It's about defining the tools, the JSON RPC methods that Claude can call to act on your behalf. By wrapping your internal SDKs into an MCP server, you give Claude the eyes and hands it needs to solve bugs that no public AI could ever understand. This move from consumer to creator is what separates a senior architect from a general user. This leads us to a bigger question. Where is all of this going by 2026? Let's look at the roadmap. We are currently witnessing the operating systemification of the development environment. In the early days, MCP was just a way to let Claude read a file. By 2026, MCP servers are evolving into autonomous agents that do not wait for your command. They monitor your logs, detect a spike in latency, and proactively suggest a hotfix PR before you even finish your coffee. We are moving from a reactive era where you ask and the AI answers to an agentic era where the MCP server acts as a background process for your career. This transition requires a mindset shift. You're no longer just writing code. You are managing a fleet of specialized AI agents. This isn't science fiction. The infrastructure is being laid right now with Cursor's Composer and Claude Code's agentic loops. Understanding this trajectory is the only way to stay relevant as an architect. You need to prepare for a future where your MCP setup is your most valuable intellectual property. Now that you know the rules and the future, are you ready to execute? I have a 24-hour action plan designed to get your first custom MCP running by tomorrow morning in the final chapter. You've seen the power of these top 7 servers, but here is the brutal truth. If you try to configure everything simultaneously, you'll end up with configuration fatigue and zero productivity gain. Within the next 24 hours, follow this specific sequence to ensure success. First, establish your local context by setting up the file system and SQLite servers. This gives Claude Code and Cursor immediate visibility into your project structure and local data. Second, move to collaboration tools, specifically GitHub and Slack. This allows the AI to understand the way behind the code through PR comments and team discussions. Finally, integrate your documentation and database layers like Notion and Supabase once your local environment is stable. Most developers fail because they start with complex cloud integrations before the AI even knows what's in the local directory. This sequence ensures that by tomorrow morning, you aren't just coding with AI, you're orchestrating a digital workforce. But installing them is just the beginning. How do you ensure your setup doesn't become obsolete in 6 months? Let's look at the long-term roadmap. We are witnessing the birth of a new standard. What we call MCP servers today will be the standard API of the 2027 enterprise landscape. In the near future, every major SaaS will ship with a native MCP endpoint as a default feature, moving beyond simple REST APIs. To stay ahead, don't just be a consumer of tools, understand the underlying protocol. I highly recommend following the official Model Context Protocol GitHub repository and monitoring community hubs like Smithery for the latest verified servers. The ultimate goal is to reach a state where your AI doesn't just suggest code snippets, but actually understands your entire business logic and infrastructure context. You have now seen the strategic framework that experienced architects use to maintain a massive output without burnout. The era of manual context switching is officially over. Your competitive advantage now lies in how effectively you can build and maintain this context bridge between your thoughts and your tools. This journey ends here, but your transformation into an AI-augmented architect starts with that first configuration command.